Welcome to this technical deep dive on the agentic SDLC and the open problems in building end-to-end systems. This video serves as a guide to understanding who owns the lifecycle, what is currently underserved, and where the next wave of infrastructure companies will be built. This is the 2026 edition. The core question is there one platform that truly handles design, coding, testing, deployment, and CI/CD using AI agents? While every vendor claims it, the reality is most of these claims are largely marketing. A platform is only genuinely end-to-end if it's native at every stage of the 8 stages of the SDLC. The verdict is no startup currently delivers a truly end-to-end solution today. The most comprehensive coverage comes from hyperscaler stacks, such as AWS and Microsoft, and DevSecOps incumbents like GitLab, who are moving to an agent-first approach. The consensus is that owning the pipeline is the key moat in this space. This matrix illustrates the end-to-end SDLC coverage. We can see that most platforms have a mix of native or first-party capabilities, partial coverage, and rely on integrations, or show outright gaps across the different stages of the SDLC. We see 3 primary philosophies for agent orchestration emerging: single-agent autonomous, persona-based multi-agent, and spec-anchored agents. Each is optimized for different use cases, such as task completion, enterprise change management, or long-term maintainability. Part 2 of this video identifies 8 open problems, underserved categories where the next infrastructure companies will be built. Problem 1 addresses the loss of memory and context across the development lifecycle. Agents are stateless across sessions, meaning every SDLC stage rebuilds context from scratch. There are issues with cross-stage context loss, long-horizon coherence, and cross-repo system reasoning. Engineering durable multi-stage memory with provenance is the area to focus on. Problem 2 focuses on verification and calibrated trust. Over 60% of AI-generated code needs human intervention, largely because we can't reliably trust the agent's output. Key issues include confidence calibration, self versus adversarial verification, and spec code drift detection. Adversarial verification, a red team agent pattern, is a wide-open area for productization. Problem 3 is multi-agent coordination. Beyond simple fan-out models like multi-devin, true collaboration, negotiation, and conflict resolution are lacking. We see gaps in agent-to-agent protocols, skill composition and conflict management, and fleet user experience for humans. Building linear for agent-driven work, with agent-native review queues and approval flows, will be a winning solution. Problem 4 highlights economics and governance. Agentic systems are non-deterministic, and their unbounded cost makes them difficult for enterprises to accept. This includes issues with cost predictability, audit and reproducibility, and liability and compliance. Outcome-based pricing models will replace per-token billing, with solutions like cost-per-merged PR driving enterprise adoption. Problem 5 addresses the production lifecycle of LLM apps, where underlying models drift. Key challenges are LLM upgrade regression risks, agent observability, and the absence of learning from production feedback. Agent SLOs as a category, focusing on LLM upgrade regression, is an underserved and time-sensitive area. Problem 6 deals with cross-cutting reasoning. Agents excel at code but struggle with systems thinking, making architecture, security, performance, and cost afterthoughts. Key pain points are architecture-level decisions, security reasoning, and cost-aware reasoning. A FinOps copilot that audits agent code for cloud cost implications presents a tangible product opportunity. Problem 7 is about generating tests that actually work, instead of merely re-encoding implementation details. The current issues are tests that don't test intent, poor edge case generation from training data, and difficulties with stateful and temporal testing. Test specialists focused on tests that test intent will continue to lead this space. Problem 8 is the human interface to agent fleets, which remains severely broken. Current collaboration tools like Slack and email are inadequate for agents. This results in poor decision delegation gradients and an inability to transfer trust between humans. The most promising solution is building seamless asynchronous agent collaboration UX, like agent-native review queues. To summarize the meta pattern, end-to-end platforms solve integration problems, while agent-first players focus on capability problems. The empty layer, the middle layer nobody owns, includes engineering memory, agent observability and SLOs, fleet UX and async collaboration, and LLM upgrade regression. This unclaimed space is where the next infrastructure companies will build value. Based on underservedness and market size, we must bet on engineering memory as a primitive, agent SLOs and task-level observability, LLM upgrade regression detection, and fleet management UX. We should avoid areas like calibrated confidence and generic AI for code, which are either too foundational or already commoditized. The key takeaway is that the competitive race is no longer focused on whose agent is the smartest. Instead, it's about whose pipeline is the most defensible. While agents are becoming ubiquitous, robust pipelines are the true differentiator and the most valuable component to own.